This is the second of a series of videos on schematics. Now, in schematic 1, we dealt with a load that was, or a schematic that was all line voltage. In other words, it was all 120 volts, it was direct switching. We didn't have to have any additional components to do like a control circuit or a low voltage circuit and a high voltage circuit. In refrigeration, most often you will see things that are 120 volts or 240 volts, all line voltage. In the rest of the HVAC field, okay, air conditioning, heating, you will have low voltage controls, usually 24 volts, controlling high voltage, high amperage devices, and those are usually 120, 240 volts and up higher. So for schematic number 2, we're going to take a look at a basic ladder diagram, something you can build on, of a low voltage control device controlling two line voltage loads. Okay, for ease here, because we haven't talked really about motors or anything yet, we're going to go ahead and use two light bulbs. Now, we're going to introduce a couple new control devices and loads in this diagram. However, hopefully we'll do it in a way that it's easily followable. So the first thing we always want to do is identify what components we need. Okay, we know we need 220 light bulbs. We know we have a low voltage switch, which a switch is a switch. Doesn't matter really that much in this case if it's low voltage. Now, what we also know we have to have in here is we have to have a transformer to give us that low voltage, and I'll show you that symbol in a minute. And we have to have some sort of device that uses low voltage but can switch to high voltage devices. So in this case, we're going to use a relay. And I'll show you that in a minute. So let's start off by drawing the basics. Okay, so we're going to draw our power supplies first. So, and let me just decrease the line width a little bit here. Okay, so starting off, okay, I always want to have some sort of safety switch in my circuit, okay? So we're going to come in here and I am going to put a safety in. Actually, let's get that in a little bit better. Okay, so just change that color and make it all relatively the same. Okay, so let's label, first of all, let's get things labeled. Okay, let's throw a safety switch in. Let's make that L. And let's go ahead and put our neutral in because we know we have to have a neutral. We cannot have a line without either a line 2 or a neutral. Okay, we'll bring them down to the same level. Now, we also know we have to have a control voltage side or a low voltage side. So let's go ahead and we're just going to draw that line in for that low voltage side. We haven't talked yet about how we're going to create that low voltage, but that will come next. Okay, so I'm going to go ahead and put that line in. Okay, to create a low voltage load, we have to have a transformer. Okay, a transformer is a device that takes high voltage power or high voltage current and moves it, makes it into a control voltage. It steps it down or changes voltage levels, I guess is the more accurate thing to say. So a transformer is relatively easy to draw. Okay, and I'm basically doing it right now. Okay, you have the iron core, And then what you do is you have a series of coils on each side of the iron core. Okay? So when this is energized, when this portion up here is energized, this is the primary side of the transformer. When it is energized, it is a load. Okay, and it produces a magnetic field. Anytime you energize a coil of wire, it produces magnetism. This side down here is considered my secondary side. Anytime I put a coil of wire into a magnetic field, it's going to produce voltage and current on the secondary side, or it's going to become a power source. Okay, so now since I have that in, let's go ahead and give that some, let's go ahead and connect that to both sides of the circuit. Okay, so now we'll label it because we always label a transformer, okay, with its input and output so that it's very clear. This is a step-down transformer. I'm taking my 120 volts and I'm taking it down to 24 volts. Let's go ahead and throw in a label here for my neutral as well. Now, a transformer's the only device that is both a source and a load. Okay, remember, this down here is my power source for my control voltage side. The top here is 120 volts. It is my load. Okay, this uses voltage and does work. This creates voltage where work can be done. Okay, so our next step in here is, let's go ahead and draw in my two light bulbs. Okay, so I'm going to come in here. I'm going to draw a bulb 1. And I'm going to draw a bulb 2. We know these bulbs can never be energized at the same time. Okay, but it has to be controlled by a switch that is on my low voltage side. So in order to control one device, one voltage from another voltage, I need to use something that's a load down here that creates something or does a switching up here. Okay, so what I'm going to use is a relay. Okay, so on the control voltage side, my relay coil, and there's different ways this can be drawn. Okay, I like using the relay coil. That sort of looks like a wave or something. Okay, so what we'll do is we'll put that into the circuit. Now, again, the key here is that a relay coil is a load. It does work. Okay, so let's go. So we have a switch here. Okay, I have my low voltage switch. We'll label everything. Okay, a relay coil can be labeled anything you want it to be, but it has to be matching the part of the relay that does the work up here. Okay, so this is a coil. When the switch closes, this relay coil becomes energized and it will create a magnetic field. Now that magnetic field will activate a set of contacts on the line voltage side. There's no electrical connection between a relay coil and the contacts which we're about to draw in up here. Now, contacts are relatively easy to draw. Okay, a contact is basically two lines. Okay, and what we can do, okay, is two lines, and then we connect it into the circuit. Okay, and then one of these, because remember I said that the bulbs will never be energized at the same time. So one of these we will treat as a normally closed contact, which a normally closed contact, the only thing different on a schematic is that we have our slash through it. Now, normally means normal position. Okay, normal position is de-energized. Okay, so in this case, the de-energized position of this contact, okay, is that it's closed, allows a path for electricity to flow through. In this case, this is a normally open contact. So if this coil is not energized, this is an open switch. Does not allow electricity to flow through. So we'll go ahead and put our line in for our light bulb, our neutral. We'll come ahead and give ourselves a power feed to both these devices. Okay. We'll go ahead and label this. Now, labeling is pretty important, okay, because we'll label this one bulb 1. And then each of these gets labeled with the same label that's on the coil. So when you look at a schematic, if you find a coil someplace, you'll be able to figure out what contacts are controlled by that coil by the labeling. Okay, so RC will have RC contacts. And in this little schematic, this is actually very easy. Okay, because you can definitely tell what coil you have here. There's only one. But once you start getting into more and more complicated schematics, your number of components on them are going to start increasing. So let's talk about sequence of operation. Okay, service switch closes. My service switch is up here. Once the service switch is closed, my transformer is getting 120 volts. It's generating 24 volts to my control circuit. Without closing SW, bulb 2 is on because my normal position of this contact is closed, allowing power to flow. Now, if I close switch SW, it's going to energize the relay coil RC, and therefore it's going to open the RC normally closed, and it's going to close the RC normally open. So what's going to happen is when this SW is closed and this coil becomes energized, it's going to swap which one of these bulbs is getting power. Of course, nothing will happen if this service switch is open because nothing is getting powered. Okay? So again, just a next step in what is considered in a basic schematic diagram. Here we're using a control voltage device to control a higher voltage load. Make sure you always get the contacts in the relay coil on the correct side of the diagram.